In today's session, Ofer Shezaf will take us through the advanced SIEM information model, now built into Microsoft Sentinel. Ofer is a principal product manager with the Microsoft Sentinel team. And without further ado, I'll turn it over to him. Ofer, the floor is yours. I think you're on mute.
I'm on mute. No, I'm not muted. Good day, everyone. As Jason said, my name is Ofer Shezaf, and I'm a product manager with the Azure Sentinel product group. My background is SIEM. I've been in the SIEM for too many years. You can see I'm not that young. I came from ArcSight, so I was there when SIEM started. When I joined Microsoft, I worked to bring Sentinel to the market. We were a very small group. We are 3 years later, and it's a successful product with a lot of people. Bringing the product to market, I met a lot of customers, maybe some of you. And I'm passionate about your and our success together. Last year, I started a new project. I started working on a hard problem, normalization in SIEM. And we started sometimes last summer, a small team. Yaron from my team is here to answer your questions. And 2 weeks ago, we made a major breakthrough. Now ASIM, our normalization framework, is built into Microsoft Sentinel. And I thought that was a good time to present to you where we are, what is normalization in Microsoft Sentinel, and how you can benefit from it. So we'll go over ASIM and understand what it is. ASIM stands, I'm not sure I wrote it anywhere here, for the Advanced Security Information Model. You need more acronyms. Here, another acronym for you. We'll discuss how to use ASIM, how you can actually benefit from it. I'll demonstrate and provide links. And then schemas are obviously core to the information model. And if time allows, we'll dig a bit down and learn about the schemas, what fields are you expecting to see there, etc. This is a part one for using ASIM. In 2 weeks, we'll have another webinars for developing ASIM. As we go further, you understand there is the user part and the developer part, and some of your questions today may be answered in the next webinar. Okay, let's do an overview and let's take that down because you don't need to see that one. Before we go into ASIM, ASIM is an information model and a framework that implements normalization within Microsoft Sentinel. So what is normalization? Normalization is the process of converting security data collected from different sources to a uniform format. It includes parsing the data into fields using consistent field names, such as, for example, source IP address or response code name, as well as consistent field values, so that response code names is known to always be NX domain when relevant. Why is normalization so important? It's the holy grail of every SIEM product, and for a very important reason. As a SIEM, we support a very large number of sources. When I started 3 years ago, it was a challenging point for Sentinel, but 3 years down the road, hundreds of connectors out there, you can collect practically any type of information you want. But now you want to get value out of this information you collect. And if each source looks differently, you need to develop the analytics, being rules, hunting queries, workbooks, etc., for each source individually, because they are different. Using normalization enables developing source-agnostic content, so one rule that works across every source. We'll see a few examples of that later on. It accelerates your ability to create analytics on top of Sentinel. It helps us provide you with out-of-the-box analytics in a scalable manner. And we already start to see that when we write a rule now. It covers dozens and dozens of sources. You get a lot more value already today with your from Sentinel because we start using ASIM. Now that's one part. The other pain point that normalization solves is making sure that when you bring your custom data to Sentinel, you get value from the out-of-the-box analytics or content. Until ASIM was there, your data came in its own format and was not compatible with built-in analytics. Now that we have ASIM, you can create one-time parser for your source to make it ASIM compatible, and with that you gain the value of a lot of the out-of-the-box analytics rules, for example, and we are extending the number of features and content items that use ASIM, and therefore will take automatically into consideration your custom data. Importantly, when I say custom data, it's both data that you bring from a system we never heard about, but way more common in the SIEM world is data that we all know about, but that you decided to bring in a different manner. For example, you have your own collection infrastructure for Windows events. You can get it to Sentinel through whatever process in between. It gets into a custom table in Microsoft Sentinel. In order now with ASIM, you can create a parser to translate to native schemas, and then this custom stream for Windows events get the value of all the Windows capable analytics within the product. The last advantage of normalization is just simplifying the analyst use of the data. When you get to the log screen or when you write a query for a rule, understanding the schema of the source is hard. I mean, it changes from source to source. Normalizing, unifying, of course, makes it easier. Source IP address is always the name of source IP address. And it's really, I don't know anymore how to use any other fields, so to speak. So just to recap, source analytics content enables developing at scale analytics, and it ensures that when you develop analytics, it supports all of your data. When we develop analytics, it supports all of all customers' data. It also enables supporting your custom data, the data we never heard about with built-in analytics, and it simplifies the analyst use of the data. So, magic, how is it done? So there are three parts to ASIM. It's a framework. The first one are schemas. Schemas are documents. Maybe I didn't prepare in advance, but I probably should do that. And go to the documentation page and show you that we have a lot of documentation about ASIM. And for example, we have a list of schemas. Each one of them is documented. So you'll see the fields that are relevant to the schema. It's a lot of documentation, but it's consistent. All schemas use roughly the same field names. If there are differences, they are because of practicalities of the data. So the schemas are documents. They are a contract between essentially us and whoever sent data in and whoever consumes data in analytics. The data will look like that. So document writing is easy, but the real test is what uses them. And there are two parts to that. First of all, content, analytic rules, workbooks, hunting queries, anything KQL-ish, and down the road, anything not KQL-ish in Microsoft Sentinel will use normalized schemas. We already converted a large number of analytic rules. We have also converted hunting queries, and we are working to convert more. Generally speaking, converting existing content to ASIM is not hard. We'll see how it works later on. The last element, the important element, are the parsers. The parsers are the technology part of ASIM. They are the part that takes the raw data, whatever you get it in, and translate it into the uniform contractual schema. We use today, in the next slide we see the architecture, query time parsing, which use KQL functions, and we'll discuss that a bit more later. So, to be a bit more technical, to get a bit under the hood, not a lot. The next webinar in 2 weeks we'll get a lot more into the under the hood stuff. Let's try to review how things work in practice. So in Microsoft Sentinel, you collect data using connectors. Those connectors send data to different tables within the local analytics workspace. Some would be generic tables such as syslog or Windows event, and some would be product-specific tables such as AWS CloudTrail or custom logs such as Okta's CL table here. Now, all those are the challenge that normalization tries to solve. They look different, they behave differently, they're hard to work with, and you have to work with each one of them specifically. How do we solve that? What we create, keep in mind that the tables are the same tables. In the current implementation of ASIM, we'll get to the left side in a second to talk about what's really, really new now. The data comes as is. The advantage is that the raw data, as you expect it, is there and will never change. It also means that there's no collection changes, no cost changes. Things are the same. What we create as part of ASIM are parsers. There's a source-specific parser, we'll use them later on, that translate a specific source, such as a Microsoft DNS server or a Infoblox DNS server, to the normalized schema. It might be from the source-specific table, so it takes all the data in the table and present it as normalized, or it might be from the syslog table, in which case the parser will also select only the relevant data for the source. All that is unified in a unifying parser, so that a single call, a single call to the data, to the view, we'll see how the view works in a few seconds, present all the, say, DNS data to the content. So a rule can now just call DNS and get results from any DNS source in the system. Before I get to the demo, which will be the next part, let's talk a bit about ingest time parsing the transformation. As I mentioned, everything on sort of this side is on the right side in your screen is done at query time. The tables do not change. It also means that you can access data as it was, no changes. You can implement ASIM in addition. Your current rules keep working. The new ASIM-based rule will work alongside. On the left side is something we just started implementing. We released, it's a major release, another major release we did last week, or the week before by now, which is ingest time transformation. You can now get your data from connectors and write it to do any parsing on it and get it into native tables, not just custom logs. Some of those tables are normalized tables. We are introducing them as we go along. There's one DNS which is in private preview. And those normalized tables are already stored in the normalized schema. It works for sources where that's what you want to happen, where the whole source gets there. The main advantage is that the data, it's an acceleration. We'll talk about the performance of ASIM later on in the presentation. The advantage of normalized tables is that the data is already normalized, so things are parser. But, and that's really important, let's scratch that, the same normalized table get through the same unifying parsers to the same content. So if you create any ASIM-based content today, it works with both query time parsing and with any data which is already received at the workspace normalized. Again, more details on that in 2 weeks' time. It's a good time to be a bit more, let's say, interesting and go into a demo. And here I'll show you how you really use ASIM and how it relates to the current way you use data. Did I remember to turn on? Let me just stop sharing for a second and make sure that I share with audio. I have done that, but I just don't want to be wrong about it. So now I should be. Anyways, this demo helps to understand the Advanced Security Information Model, ASIM, Microsoft Sentinel's normalization framework. We will also see how it makes querying data in Microsoft Sentinel easier and more powerful. First, let's see what the data looks like without ASIM. We will start with Zscaler. As you can see, Zscaler sends events in the common event format Ceph. Zscaler DNS events share the common security log table with many other sources. Therefore, to query Zscaler DNS logs, the analyst must know the obscure device product NNS DNS log. Since Ceph is supposedly a normalized format, the result should be very easy to use. But if we look at the record, we notice that the essential values are stored in custom fields requiring significant expertise to use. For example, the response code is stored in a custom field. Now, let's look at the Azure Firewall DNS logs. Again, you can see that the analyst needs to be very knowledgeable to select the relevant events from the Azure Diagnostics table. The results are easier to use as the data relevant to DNS is presented in the message field. While this format is readable to humans, it is challenging to machine analysis, for example, detection rules. Last but not least, let's look at the Microsoft on-prem DNS server logs. Surprisingly, this legacy system provides the most structured logs. However, the DNS response codes are presented in a numerical format, making them hard to use and inconsistent with the other systems we've seen. Now, let's turn to ASIM and see how it addresses these challenges. To use ASIM, use an ASIM view instead of the specific table in your queries. We can see that the fields are returned in a consistent and structured manner. For example, the response code is marked as such and uses consistent labels. Now, repeating the query with a small KQL trick enables us to see a couple of the events from each of the sources we have met. Notice how ASIM queries all data sources at once and makes events from all sources similar. By querying over all similar sources and returning a unified and consistent response, ASIM makes querying easier and enables SOC engineers to create rules once that will work on many sources. So I hope the demo was able to articulate and explain the tough diagram. The important part to mention, you've seen the IAM DNS view. It's a log analytics function. It parses and combines the sources at query time. So it doesn't change the underlying data, which has a lot of advantages. We'll talk about the performance impact a little later on. This is the right side. On the left side, we are now introducing a native DNS connector that will use the normalized table. It will be part of the same IAM DNS function, even though it uses pre-normalized data. So a bit about the details. I will not go into every word and element here. We have covered two main areas with normalization so far. One of them is the network suite, network protocols. We covered three important ones actually, DNS, network, and web. We are adding a lot more in coming months, though the first three are the most important for content. As you can see, we are extending the number of parsers we have considerably. We have very considerable coverage around DNS, nearly every source you would know. And we have a lot around network session, and we keep working. We are in the midst of adding more web session parsers. The second area is endpoint, process events, file activity registry. Today we cover most, not just, we also have authentication, AWS and Okta, Microsoft sources. We plan to add third-party sources. That said, it also provides significant advantage. For example, the same content item would support Microsoft Defender for endpoint, Windows security events, Sysmon events, and we'd cover both Windows and Linux, Linux through Sysmon or Defender for endpoint. So if you write, if you do analytics, if you search over network data or endpoint data, we are already there. If the parser for your source is not yet available, we'd love to get it as a feature request. We need to prioritize after all. Getting a bit into the details, you've seen the _IAM_DNS table. There's also IAM_web session table, etc. for all the relevant schemas. We have two types of parsers. First of all, as I mentioned, as we introduced just last week, now every let's look at browser. Every workspace now has in the Microsoft Sentinel solution the relevant functions built in. So the source-specific parsers and the unifying parser which you actually use. It's there whenever you start a workspace. It's already there. The advantage is that you can write content to use it without having it just will work like any table. We also have a version which is where we started. You'll see it here, which is a workspace function. You need to deploy it. You deploy it from GitHub. This was sort of the old solution where we started until 2 weeks ago. There are some schemas that we did not already implement built in. So you'll still need the workspace functions. We'll get to do the built-in as well. Since it's all views, doesn't change the data, it's side by side. If you write a rule for this one, it's fine. If you write a rule for this one, it's fine. Going back to the slide and comparing a bit, the built-in functions are the way to go. They are easy to use. They are there. You can, if you want to change something, there is in the documentation a way to customize the built-in one. You cannot change directly. You'll have to copy and customize, and then include your version in the unifying parser. And usually you lose those. Workspace deployed ones are still used for a few schemas that are not built in yet, as well as for development, are much easier for development. That's why you'll sometimes see with underscore at the start, which is anything built in log analytics, and without for workspace deployed, which are just for specific workspace. So we did a demo. You saw a bit about how to use ASIM, but let's go into the details and see how it works in real, step by step. So first of all, you need to start with the view. The slide here, which you'll get as part of the slide deck that you'll receive, and is also available in the documentation I pointed out earlier, is the view. You need to start from the relevant view. You see that we have 3 built-in schemas, network, web, and DNS, and another 4 schemas that you will need to use the workspace-based functions. So if you want to write a normalized authentication query, say brute force across all sources, keep in mind, it's interesting. Brute force across all sources is not just brute force for each source, it's across sources. If you write it using IAM authentication, it means that if somebody fails to log in on Amazon and succeed to log in on Azure or on-prem, you'll detect that. You'll use IAM authentication. You want to identify malicious IP addresses in your network stream, you'll use IAM network session, etc. You may have seen that we have 2 sides to that, IAM and ASIM. Usually, the IAM ones, the shorter ones, are the right ones. They have advantages we'll discuss a bit later. Why do we have the ASIM parsers? So we're trying to resolve a log analytics limitation. You can see here that if I'm using the IAM parser, when I type IAM, I can show you that in an actual window. You see that here it writes 24 hours, and I do IAM DNS, it changes to setting query automatically. There's nothing bad about it. You can go back to last 24 hours. It will work fine. It is confusing, and an analyst may type IAM DNS, not notice, and search over all retained data, which will take long. The ASIM version is supposed. There's a bug in that we are resolving as of now to not have the issue and not change the last 24 hours mark. So it's easier for an analyst. Anywhere else in rules, workbooks, hunting queries, and also interactively, if you want, you can use IM. Use ASIM. ASIM is sort of for less experienced analysts, so they don't make the mistake with time range picker. Now, let's look at the same query that we saw on the first slide when I explained what normalization is. How do we write a query using normalized schemas? So we already know by now that we start with a normalized view. It's like a table. It's no different than any other table in the user point of view. There's a lot of technology behind it. When you develop for ASIM, you work to make that happen, but you just start like that. The second thing is that you need to use standard field names. It's easier. You learn them once, you know them all, such as response code name or source IP address. Source IP address is specifically of interest. It's always the name of the source IP address across every source, which is something that without ASIM is not the case in Sentinel. Lastly and importantly, the values are also important. One of the challenges with normalization is that, and in the demonstration video you've seen that, the response code may be presented differently by different sources. For example, the Microsoft DNS connector sends the response code in a numerical format. In ASIM, we make sure that you always get consistent values so that your queries work. Those are documented. We write what are the expected values in the schema documentation. Why is it good? So let's take a real world example of a normalized rule that we converted. It's for registry this time. And let's look at the old rule and the new rule. So the old rule had to do a union between a section handling each possible source. It was limited only to the sources that were in the developer mind, or that he knew how to handle. Obviously, with normalization, you don't need that. The second thing is actually very interesting. You'll notice here that in the security event, the registry hive is using this name. But if you use sysmon to report the same exact activity, the registry hive name is HKLM instead of a registry machine. So you really need to know it's different. It's not easy. Normalization takes care of that as well. We make a choice as to the right format, and every parser has to convert to that. In this case, it's a third one because it's the format, the native format used by Defender for Endpoint. But when you use IAM registry, it will go and will make sure that it works well on all the sources, so security events or sysmon. Now, another point to consider, and that's an important one for performance reasons, is that parsing is still needed. The code for sysmon has heavy parsing in it, and it's hard parsing. It's also hard parsing to maintain if you need to write it yourself. And to share with you, this one is also incorrect. So the query on the right takes care of on any supported source. For registry, which is very Windows specific today, it's Defender for Endpoint. It's security events collected as security events. It's Windows events connected using WEF. It's sysmon collected using event, and it's sysmon using Windows event. So even though it's just 3 sources, it's 5 types of data you need to consider if you don't use normalization. And it solves the issue with the inconsistency in values. All in all, you can see that the right side is so much simpler than the left side to make using ASIM a real bonus. Now, before I get to, I'll explain and then I'll show you in a demo why it matters. I mentioned before that we have 2 types of parsers. The core one is IAM, and the secondary one for specific reason ASIM. Behind the scenes, the AM parsers have a very specific attribute to them that is built for performance. You can see here that on the right side, I use standard KQL somewhere along the way. We'll see why later on, to check the response code is NX domain. Here, I do it as a parameter to IMDNS. It's not as obvious, you need to learn that, but it provides a performance improvement, which is second to none, and we'll discuss it a bit in a second. Let's start first by looking here. I ran the queries before just because it's demo and they take time. You'll see here that this query, which is a standard query using IMDNS, using standard KQL, took around 7.5 seconds to run, and its second run took twice as much in the first run. And you also got to know that it's excessive in terms of resource consumption. It is a challenge with normalization. The challenge is that, or with parsing in general, I should say, we'll see it in a second, that IMDNS first parses 180 days of data, and then does the workloads on the DNS query. This is obviously inefficient. The second option, the second alternative here is to use the parameters for IMDNS. It's the same it's the same exact same conditions. We check for time, we check for an IOC, but we do it as parameters. Okay, and here it took 3.5 seconds. Remember, it was 7.5 seconds in the previous example. By the way, if you are log analytics users, I had a heart attack this morning because this number used to be here and now it moved here. And I thought my demo would not work. Where's the number? Anyways, anecdotal. Anyways, so by using parameters with IMDNS, I was able to reduce the time it takes 5-fold. And that's on a relatively small data set, though from multiple DNS sources. In a larger data set, it's dramatic. Keep in mind, that's when I wanted to use 180 days. If you run if you run queries over a day or two, the challenge is not as hard. However, in practice, and that's where I get back to the slide, you do parsing also without normalization. Infoblox is a parser. So the same challenge that I presented before happens with Infoblox anyways. And with typical parsers, you don't have the benefit of adding filters to accelerate. Moreover, we've seen that making queries right, filtering correctly for performance, which is possible, is not always intuitive. I'm good with that. So many times I get a query and people come and say it doesn't work, and I can switch 3 things around and get it to work much faster. And it looks like magic. The challenge is that if I can do it and if others didn't do it before, it means that it's not intuitive and it's hard to do. In this respect, the new filter parameters for ASIM makes creating a performant queries much easier. If we look at the query on the left, it's specific to Infoblox, while obviously IMDNS queries any source. It also does parsing, so it parses all data anyways to start with. Moreover, then of all the data parsed, we actually select one type of data because Infoblox has a lot of event types. All of them are parsed. We want only DNS logs, which are characterized by, delete all that, by the name D process name and by log type client. Okay, so after parsing everything, we select a very small part. And then we do the filtering over parsed data, which is very inefficient. On the other hand, on the IMDNS version, we first search across all DNS sources available, And the parsers behind the scenes, again, come in 2 weeks' time to understand how it happens. Make sure that the filtering is done prior to parsing in a very, very efficient manner, which is a way to make ASIM works faster, but in most cases also a way to make your queries faster. Even though they can be optimized, they're usually not optimized. ASIM makes it just much easier to optimize. And it's much simpler. And I did all the demos. Instead of going into the schema details, it's just too much information. Let's see if there's something here. I'll skip that for now. It's just a lot of information to learn. You can browse the presentation when you get it. I think that I'll go into a glimpse of the behind the scenes to make it a bit less of what the heck is he talking about, how that can happen at all, and show you another video that explains how things are done behind the scenes.
One thing to highlight here is the importance of the Advanced Security Information Model, or ASIM, which is the guiding framework to which normalization happens within Microsoft Sentinel. Let's take an example of a hypothetical proprietary network solution and see how we can leverage ASIM to easily apply existing detections on this custom data source. Here, I'm ingesting a custom network log that provides two main fields, one event info and another being the event message. Now, looking into the message field, there is some consistency in the way the entries are being written. And what we can do here is to use the parse function, which allows us to essentially build a key value pair and match the structure of the entry into the different components we would like to extract. So herein, you'll notice we're extracting network protocol, which would be TCP or UDP. We have and will exclude the request from text and continue to pull out things like source IP address, port number, etc. Alternatively, you could use regex parsing as well if preferred. Running this, you'll notice that the long entry has now been parsed neatly into our desired columns. Coming back to the other field of interest, which was event info, just from visual inspection, we can observe that a good delimiter to use in this case would be a space. In such a case, we can leverage another parsing mechanism called split, which will break out the text entry using a space as the delimiter. Running this, you notice now that we have a very neatly parsed array containing the three different event info components. So let's say I was only interested in these two fields. We can simply click in and extend the two columns. Now, before we rename these fields, it would be useful to look into the ASIM network model to understand what are the available and preferred field names. Coming back to our original parsing query, we can now rename this into destination zone, and the second one we'll rename to network session ID. Running this, you'll notice that destination zone and network session ID have been pulled out. So let's just add a couple of finishing touches. You notice in here that my log source did not provide an event vendor name, but I would like to identify what this log source is. And we can do so by extending and appending a custom name for this event vendor. And perhaps you'd like to store your raw data neatly in one column. We can use a pack function to do so. And let's project away any temporary columns for cleanup. So here, you notice we end up with a very neatly parsed event package, drastically different from what we had originally, rendering it much more usable, while still retaining our original data as well. What we'll do next is to save this as a function, and let's call it ASIM Network Session Custom. The next thing we need to do is to go into the ASIM Network Session function and add our custom parser into the union. This function essentially identifies which underlying data sources should be abstracted into the broader ASIM network group. So now, if we were to query the ASIM network session table, we're able to immediately access all other underlying network data sources, whether it be Palo Alto, Zscaler, Linux Sysmon, and more. Using this partition query, we're just going to showcase two entries per unique event vendor. And you'll notice we have Palo Alto here, Microsoft VM connection, and of course, the proprietary network solution we just added.
Where are my slides? Somewhere here. Anyways, I do hope that was useful to you. Let me try to recap and talk about, go to the relevant slide for that somewhere at the beginning, where we are and why it is important to you. So ASIM is Sentinel's normalization framework. It was here for the last few months, but it was harder to use and you could not take it for granted to be in. As of 2 weeks ago, at least the network side, is built into your workspaces. This means that we can convert all our content to work over the normalized data and that you can build content to work over normalized data. It means that you'll get a lot more value out of the data you stream into the workspace. Also, by creating a parser, and at this point in time, my team is here to support and work with you to try to do that. Because we are just starting to have customers write their own. You can include your data in the built-in content, which is a great bonus for getting more data into Sentinel. And I do urge your analysts to start working with the ASIM views. It's just much easier instead of trying to understand the specifics of, say, AWS VPC network logs. We normalize them. So if you already know how to use the normalized network schema, you know how to use VPC logs. The complex JSONs for GCP DNS, hard, but we already normalized them to the DNS schema. So just use it directly and you get very easy access to the logs. So write content using ASIM, develop your parsers with our help to start with, to make sure that your data get value out of the building content, and work with your analyst, or if you're an analyst, to use ASIM to just simplify your life. In a way, that's the way forward. Internally, we are converting everything to ASIM. ASIM is the heart of whatever we do. It's the linkage between connectors and analytics, and implies that they don't have to be bind together, creating an unmanageable mesh. Connectors on the bottom, content on the top, and ASIM creating the link in a manageable manner. So I hope that was useful to you. I'm sure it raises a lot of questions. I'm open to answering them now. And let's go to people view, so that people who want to ask can ask. Those are just the Microsoft people. And keep in mind, in 2 weeks there is a second webinar. We'll dive under the hood and talk a bit about mostly how to develop and manage parsers. I'll show the same last demonstration video again at the beginning of the next one, and go from there.
Hey, Ofer, talking about that webinar in 2 weeks from now, there were folks asking, in fact, for this webinar, if it's going to be hands-on. So is that one going to be hands-on?
The next one?
Mm-hmm.
I might have hands-on, meaning customers doing,
yes,
listeners doing themselves during the webinar. No, I don't think so. I think, but it's a good idea. We need to work to have something like that, more for a lab. Webinars are not the best. 50 minutes webinars are not the best venue for hands-on, but I understand the requirement and the need, and we need to think about how to do that.
Cool. Well, thanks for your presentation. And before I let Yaron verbalize the unanswered questions, I just wanted to remind folks that this is a public webinar. And because of that, we just can't go into the deeper conversations when it comes to roadmaps and future features coming up and all that. So a good venue for that, I have already posted a link, is our Microsoft Cloud Security Private Community Program. Please visit aka.ms/prseccom to register for that. So thank you, Ofer, and I'll let you guys proceed with the questions.
Okay, so I'll read some of the questions that were asked during the session.
Before you do, Yaron, you see his picture now with the blue circle. Yaron is the wizard behind all of what you've seen, so just be aware of that. Thanks, Yaron. Yes, but he let me answer the question even though he could do it himself. Yes, please.
One question is to confirm: does this approach allow for us to get the same features and benefits within Sentinel, such as standardized analytic rules and UEBA, in cases where we ingest logs in a custom way? For example, sending OS logs to CloudWatch, ingesting CloudWatch as custom table to Sentinel, and then conforming to ASIM.
So the answer to that is a partial. The end game is yes. Valon said I shouldn't talk about roadmap. I just did. And he's smiling in his picture. I should have a smiling picture as well. Some areas,
I am
mostly
smiling actually.
Yeah. Nothing. Most of the KQL-based feature already support that today. So analytic rules, hunting queries, we are very close to do it with expansion queries, for example. The features which are not based on KQL, such as UEBA or parts of UEBA, will take a bit more time to adjust to that. So that's down the road. When I say UEBA, and I say not all of UEBA, so for example, entity pages are largely built on KQL, so they will benefit in the short term. So thanks for the question, and it's a good clarification. It's a journey, and everything I demonstrated, most of what I talk about exists today. The level of embedding within the feature within Sentinel is different between the features. We are working to make it complete. So Yaron is selected good questions. Thank you. And any other important question, Yaron?
Yes, indeed. There were several questions that I will merge to one question about the roadmap. So people asked about the roadmap in the sense of what are the next schemas after the 6 that we already have that we plan. Also, what content and timeline for rules, analytic rules, and workbook, and also about ingestion time normalization. What's planned about this area?
So a lot of questions, and as Valon mentioned, I'm not going to talk about timeline, so I'll talk a bit more generally to the extent possible. I'll start with schemas because I think the others is a lot about when does it come. Schemas are more interesting. We do think that the schemas we cover today cover the most important areas. There's one area where we've started tackling, and it is important, and it is audit. So we are mostly focused on activity, and network and endpoint activity or server activity are the core of the activity out there. Audit is, for example, firewall policy changes or user management. Those are harder to schematize. They don't fall into a neat paradigm as would activity. But we are tackling that. We have released recently our first audit schema, user management, and we are starting to work on Parsers for it. And our major project for the coming months around schemas is schematizing audit. There are odds and ends also with activities such as email, which is in the works. So that's the first one. The other area where we are just working, and I mentioned that before, is creating more parsers. It's work. We need to convert existing connectors to support parsers. Your input, your requirements, what's important to you is a very important, as usual, driver for where we invest our time and effort. So keep that in mind. I also mentioned that in terms of content, everything KQL-ish is rapidly being done. I can't get into the timeline, but we're working hard to make it happen. We expect the endpoint related schemas to be built in the next few months, which will enable us to convert a lot of the content, I would say, the KQL based content. For content which is not based on KQL, such as some of the UEBA functionality, it will take more time, and again, no timeline today, as Valon mentioned, or was it Jason? Registering to our private preview community would help here. The last comment about ingest time transformation. we announced the capability to transform data at inches time last week or 2 weeks before, so it's now public. In practice, it means that you can start experimenting with inches time normalization now. It would not be into standard tables; it would be into custom normalized tables. So you need a small parser to just take it and get it into the unifying parser. We'll make it more productized over the next, well, no date, sorry, but we are working on that. But the core capability, which I've been promising for quite a long time, is now there, which is the big news. Probably a much bigger news than even ASIM being built in. Just if you missed the announcement about instance transformation, it's a very important one. It's a major breakthrough for Microsoft Sentinel. It's good for normalization, it's good for parsing. It enables a lot of other use cases. Think about data masking, filtering. So a major leapfrogging for Sentinel that was announced 2 weeks ago or last week, was it? Anyways, if you missed that, well, do we have a webinar on that?
On which one? Sorry, I missed that.
Pipeline transformation.
Pipeline transformation. It doesn't ring the bell, but sure, we'll get one going.
Okay. Maybe there's a different name. It should be Oded and Evgeny. Anyways, so if look for one, it's a very important advancement which supports my normalization, but also a lot of your other use cases. So, Yaron, any one or two last questions?
Sorry, I was on mute. Yes.
Just Benjamin commented. You all saw it popping that there will be a webinar in May on pipeline transformation. Thank you, Benjamin. Yes, Yaron.
Yes, we also got several questions about where to go to contribute and to report bugs or to get help.
Oh, it's a good one. So there are two parts to that. If you want to report bugs, I do suggest at the end of the day, at this point in time, if you'll just go to the Azure Sentinel at Microsoft.com email address and send an email, it's fine. I do think that the right way to report bugs or issues is support. They'll get to us. If it's hard, if you prefer through our GitHub, we manage the parsers are like analytic rules. The parsers are created and managed in GitHub, in our Microsoft Sentinel GitHub. And from there, like rule templates, they are selected and converted into the product to be built in. So you can also report bugs on GitHub. We have people who have done that before. And it gets to contributing, since it's on GitHub, you can contribute. We do have a significant documentation about writing parsers. We still not create the missing link of if you created a parser, how you contribute it on GitHub. Probably something we should do. If you want to, don't hesitate. Reach out to us through GitHub or otherwise, and we'll accelerate writing the guide for you. We would love you to contribute, of course. Thank you all. Unless there is one last question, we are at time. I hope that was helpful for you. And again, that's part one. Part two, which would not be hands-on, but I want to do a lot of demos to compensate, will be under the hood and will be in 2 weeks' time.
Great. Thank you, Ofer, for being our guest today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve these webinars. please take a minute submitting your webinar feedback at aka.ms/security webinar feedback. Thank you and see you next time. Goodbye.